bucka. Haha. You know the deal.
The next thing we're going to talk about with fractions is fractions and decimals. And as we've talked about, fractions describe part of a whole. That's really the purpose of a fraction. Well, similarly, decimals also describe parts of a whole. So if you look towards the bottom of the page here, we have a number line. And the number line here, it counts in 100s. Now, in between the hundreds here, we do have values. So in between, from 0 to 100, from 300 to 400, we do have values in between those values. And those values there would be the tens. And we have 10 tens to get to 100. So we go 10, 20, 30, 40, 50, 60, 70, 80, 90. And then we've got 10 tens. Well, 10 tens is 100. So we do have values in between the hundreds, and they are the tens. So here, I've changed the number line. So rather than counting in hundreds, now we're counting in tens. But once again, we do, of course, have values in between these values. And the values in between the tens here would be the ones. So it takes 10 ones to get to 10. So those little ticks there are counting in ones. We count up to 9, and then we have 9 ones. Well, 10 ones is the number 10. Well, now our number line is counting in ones. And just like before, we do have values that are in between the ones, smaller than the ones here. That we count in between the ones. And now we've got just whole numbers here. So to describe the parts of these whole numbers, well, we could use fractions. Fractions have been used before, and we could use fractions to describe these whole numbers. Like, for example, the number 2 can be written as 2 over 1. 2 divided by 1 is the same as 2, so 2 wholes is written as 2 over 1. But in between these values, we do have parts of whole numbers. And up till this point, we've described those as fractions. So if I look a little closer at the ones here, I can see that I have 10 pieces in between the ones here. So if I were to draw a section up to here on my first one and shade that in, well, you can see there, if that shaded part represents a part of a whole, I have 5 pieces shaded there out of 10 pieces. So if I wanted to write that section there as a fraction, that section would be 5 out of 10, which would reduce to 1 out of 2, which makes sense because that piece there is half of a whole. So we have 1 over 2 pieces, a half there. Well, if I extend that line to look a little bit bigger, and I can see those 5 pieces now, well, now you can see there's actually a label for that point there, and that's 0.5, which makes sense because what we're counting in here in between the holes are tenths. So the place value smaller than ones is tenths. So what we have here are 10 tenths, 0.1, 0.2, 0.3, squeeze it in here, 0.4, 0.5 is labeled, so next we have 0.6, 0.7, 0.8, and then here's the last one, which is 9 tenths, and then we get to 10 tenths. Well, 10 tenths is a whole, 1, or 1 decimal 0. So if you recall, that piece of the whole there was 5 out of 10 pieces. Well, 5 out of 10, as we saw, was the same as a half, if we reduce that to simplest form. But what we can see here on our number line is that's the same as 0.5. Well, if I take that shaded piece and suppose I, instead of making it half of the whole that's there, I just draw it so it's that much of the whole. Well, as we saw before when we were counting in tenths, which is what we have here, the value that I really have there, the first one there is 0.1, and then I have 0.2. Well, if I look at that as a fraction, that's 2 pieces there. We have 2 pieces out of 10 pieces altogether. So we could write that as a fraction, 2 out of 10, because it's 2 pieces out of 10 pieces, and if we reduce that fraction, that's the same as 1 over 5. But as we can see from the number line here, well, 2 pieces out of 10 pieces of a whole is the same as 0.2. Suppose I made my piece of the whole that big. Well, if we count the pieces there, there are 7 pieces out of those 10 pieces. So if we were going to write that as a fraction, that would be 7 out of 10. Because we've got our one piece here, our second section is there, then our third, fourth, our fifth section, sixth, and seventh. So we have 7 pieces there out of 8, 9, 10 to get up to one whole. So that's 7 out of 10. Can't reduce that fraction, but if we look at the decimal form there, if we're counting in tenths, it would go 0.5, 0.6, and then we would have 0.7. So here are 3 examples where we can see equivalent values between a fraction form and a decimal form. And in order to explore this, all I really did was I broke a whole, just one, up into 10 pieces. And those 10 pieces are called tenths. So if we're counting in decimals, it starts at 0.1, it goes up to 0.9, and then when we have 10 tenths, we have a whole. So when I break that into pieces, just like I did with a pizza, it's always out of 10 because there are 10 pieces there. We could see here that for when I did half of the line, it was 5 out of 10 pieces, or half, which was 0.5. And the same thing with the other examples. We just had then 2 out of 10 pieces, which reduces to 1 out of 5. 7 out of 10, which we couldn't reduce, and we saw the equivalent decimals there. Well, let's look at an example where I draw a piece that's that big. So first thing we have to remember when we have a diagram that's more than a whole, in the denominator we always put how many pieces each whole is broken into. And for this picture, each whole up to 1 here, the whole is broken into 10 pieces. You can see there are 10 sections there. 5 of them are up to here, 10 of them are up to here, and so on. So each one whole is broken into 10 pieces. Well, if each whole is broken into 10 pieces, 20 of them go up to this point. Now, as we can see from the picture, at that point it's 2 wholes. Looking at the fraction, we know that 20 over 10 is 2 wholes, because as we discussed a lot in this unit up to this point, a fraction is really just a division question, and the division question here is 20 divided by 10. 20 divided by 10 is 2. So if we look at the previous examples, well, all of them are division questions. This one's a nice easy one because we're dividing by 10. 7 divided by 10, if I were to write that over here, well, we know that if we're dividing by a power of 10, we're moving the decimal. And if it's a power of 10 greater than 1, we're moving the decimal to the left. The decimal's starting there. We need to move it 1 place to the left. So that does equal 0.7, 7 divided by 10. Going back to the first one that we did here, well, we had 5 over 10, and 5 divided by 10 means we move the decimal 1 place to the left, so we get 0.5. Now, if you have a calculator handy, try doing 1 divided by 2 and see what you get. Similarly for the next one, here we have 2 divided by 10. 2 divided by 10 means we move the decimal place 1 place to the left, so we get 0.2. Again, if you have a calculator handy, try to do 1 divided by 5, because again, a fraction is just a division question. The top divided by the bottom. So since a fraction is just a division question, to change a fraction to a decimal, or just to a number, which is really what a decimal is, we just answer the division question. Here the division question is 3 divided by 4, because we have 3 in the numerator and 4 in the denominator. Well, if you've got a calculator handy, it does help with this type of question. 3 divided by 4 is 0.75. We can check that by doing long division. If I'm trying to divide 4 into 3, well, 4 doesn't go into 3, so I've got to put my decimal and add as many zeros after this as I want. 4 does go into 30, however, 7 times. And we know for long division, we just put the decimal right above. 7 times 4 is 28. Drop down the 0, the remainder. 20 divided by 4 is 5, and we have a remainder of 0. So we could keep writing zeros after that, but we usually stop at the 0 once we get to the last 0. So 3 divided by 4 is 0.75. So to change a fraction to a decimal, again, you just do the division question, the top divided by the bottom. Suppose we have something like this, though, 1 divided by 3. Well, if you try that on your calculator, what you're going to find is you get 0.33333, and those 3's go on forever, because we keep getting a remainder if we were to do this with the long division. So there's a couple of ways you can write that if you have what's called a repeating decimal. A repeating decimal means you have a section that repeats over and over and over again. One way is to put a line over the part that repeats, and in this case it's the 3 that repeats over and over again. So we put a line over the 3. If you try 1 divided by 11, you'll find you get 0.090909. So in that case, it's the 0.9 that repeats. So we put a line over the whole thing that repeats there. And the whole thing that repeats over and over again is 0.9. So we've talked about how to change a fraction into a decimal, and to change a fraction into a decimal you just basically do the division, top divided by the bottom, and you've got your decimal. To go the other way, to change a decimal to a fraction, there are a few different ways to do it. This is an introductory way that we're going to look at, and until you get to grade 9 we're only going to be dealing with non-repeating decimals, so decimals that just stop. So, for example, if we take a decimal like 0.13, well, what we have there is a number, and we have to write that number as a fraction. So if you recall, whenever we had to write a whole number as a fraction, so for example, if you were given the number 8, and you had to write that as a fraction, you would write that as 8 over 1. Now, there are a few different ways you could write 8. You could write it as 16 over 2, or 24 over 3. As long as the division question equaled 8, any of those are correct. But usually the easiest way to write 8 as a fraction is to just put 1 in the denominator. So similarly, to start to put 0.13 as a fraction, we're going to just put it over 1. Just like with 8, to make 8 a fraction, we make it 8 over 1. To start to make 0.13 as a fraction, we put 0.13 over 1. Now the only thing here is we're not allowed to have a decimal in a fraction. So we need to get rid of that decimal. And where do we need to put it? Well, we need to move it 1, 2 places to the right. And then it'll be after the 3. And then instead of having 0.13, we'll have 13. So how do we move a decimal to the right? Well, we times it by a power of 10. And in this case, we times it by 100 because we want to move it 2 places to the right. With equivalent fractions, whatever we do to the top, we have to do to the bottom. So when we go ahead and multiply those, we get 13 over 100. And if you check on your calculator, 13 divided by 100 is 0.13. Let's look at another example where we have a terminating decimal. So here we just have 0.125. And again, when I say terminating, I mean there's nothing after the 5. We could write zeros after that 5, but then it would just go on forever. There are no numbers after that 5, so it just terminates, it just stops. So if we want to write that as a fraction, we'll start by putting it over 1. And now, as we saw with the last example, we want to get rid of that decimal, so we want to move it 2 places to the right, which means we have to multiply by 100. Whatever we do to the top, we have to do to the bottom. So when we do that, we get 125 over 100. Now there's a couple of issues with this fraction. It's not in simplest form, and it's an improper fraction. I'm going to start with the fact that it's an improper fraction and make it into a mixed number. So when I do 125 divided by 100, and I'm not changing it to a decimal, but a mixed number, I get 1 whole, and my remainder is 25. The denominator stays the same. Now that fraction 25 over 100 can be reduced. Both 25 and 100 can be divided by 25, and I get 1 1/4. Now, if you're changing this back to a decimal, we have 1 whole and 1/4. So I have 1 whole, and then if you do 1 divided by 4, you'll find you'll get 0.25. But don't forget we had that 1 whole at the beginning here as well. So it's not 0.25. If we have 1 1/4, it's 1.25. So to finish off our lesson on the connection between fractions and decimals, I'm going to ask you to do a couple of things here. With the first 4 questions there, you've got fractions, so I want you to change those into decimals. If it's a repeating decimal, indicate the part that is repeating by just drawing a line over it. For the next 3 questions, 1, 2, and 3 there, we've got decimals, and what I want you to do is change those to fractions. Now remember, if they're fractions, they have to be in simplest form, and if it's an improper fraction, you have to change it into a mixed number. If you're able to do that, congratulations, you now have a firm understanding of the connection between fractions and decimals.